Hello, this is my Lab 5 report for the Choose Your Own Adventure Lab, and I decided to analyze the Cristiano Ronaldo celebration that he does when he plays soccer. So the introduction, the problem that we're trying to do is compare the motion of Cristiano Ronaldo doing his iconic celebration in real time with a computer model coded in Glow script. The overarching fundamental principle is Newton's second law of motion, and it is going to be shown by this velocity update formula, and we will also be using the position update formula as well. So this video is organized into these 4 parts. First, we're going to watch the tracker video. Then we're going to look at the Glow script code. And then we're going to compare the Glow script model with the experimental data from tracker. And then we will discuss the discrepancies between the models and the tracker video. So first, let's look at the tracker video itself. So this is from a match between Udinese and Juventus. So here we go. Let's watch it. Boom. There we go. So you can clearly see, here's our data. So here we can see Ronaldo jump into the air and do his iconic celebration. And we will only track up to 0.9 seconds here because I just include the rest because I want the full celebration in the video, but the rest of the data doesn't really matter. So the calibration stick is set to 1.854 meters because that's his height according to Google. And I position the axis at the center of his chest, as you can see here. And then I followed the center of his chest as he went through the entire motion, as I consider that his center of mass. So for the actual Glow script code, we have it right here. So you can see that I set the mass to 84,000 grams since he has 84 kilograms according to Google. So that would be right there. Ball to M. And then we need an X velocity and a Y velocity as it is indeed 2D motion. X velocity is constant as we assume no friction, as Ronaldo is too mighty for air resistance. And we calculate it by getting two random points and getting the change in distance over the change in time for the X velocity. So we got that data from tracker and I plugged it in here. I showed you the calculation and it's 1.70 meters per second. Then the Y velocity was subject to Newton's second law since there's gravity. So I got the initial Y velocity and calculated it in the same fashion as the X velocity, and it came out as 4.3 meters per second. And for the actual analyzing, we will only analyze the Y motion or the Y velocity as X motion remains constant the entire time. So that essentially will be a straight line. So we can clearly see in the Glow script code, we have our initial Y velocity and our initial X velocity as determined before, as I showed on the previous slide. And our delta t time step will just be 0.01 seconds. And as you can see, we're going up to 0.9 seconds. So let's run the program. So here we go. Here we can see the position versus time. And we can see that this roughly aligns with the X with both the X and the Y graphs from the tracker. As you can see, it starts from around here and it dips all the way down to there below where it actually started, which is accurate because it started here at 0 and actually fell below 0 for both the X and the Y graphs. So we can clearly see that the actual positioning from a rough look actually looks accurate. But now let's look at actually compared in Google Sheets. So here is the actual chart of experimental position versus model position over time of a falling object, which essentially is Ronaldo in this case. So we can clearly see that our experimental position, while the model and the experiment did follow a roughly same trajectory for the first 0.3 seconds, it does deviate very quickly as we go from 0.3 to the 0.9, where the model position follows the same parabolic curve, while the experimental position seems to follow a very much more jagged curve. So let's discuss the discrepancies. Well, I already told you we can see a clear discrepancy as the model overshoots the data from 0.3 to 0.9 seconds. And I believe the possible causes are these. First, I took the video with a phone of a computer screen. And of course, I maybe not held the phone completely horizontally the entire time, which could have caused some sort of deviations. Also, you can see that in the actual video, the camera followed the player. So it wasn't a complete two-dimensional view. So you can clearly see that the ground is at an angle. So we're not looking at it as at a complete two-dimensional fashion. So it's probably a 3D motion. And we can see that the camera actually follows his motion the entire way, which probably means that it's not going to be accurate when we tried to predict it with Glow script. And so also we can probably guess that tracking the chest as the center of mass is inaccurate because the center of his mass is probably not in his chest. It might be somewhere else, maybe a bit lower, maybe a bit higher. And also there's air resistance that is not just relative to the mass, because air resistance will also be relative to the surface area of Ronaldo. And that is something that we have not discussed yet in class. Thank you.